Hi guys! Today I'll show you how to turn almost any object into a needed one. We'll see how to transfer textures, patterns, even colors from our geometry onto the needed surface. For this tutorial I'll use the skull as an example and we'll build the setup from scratch, and then we'll try to render it in Redshift. So let's dive into Houdini.
Okay, let's get off.
Let's start from the creating geo container and we'll name it skull need. Going inside, I got a reference image from Pinterest that shows how the need should look. And if we break down the problem, as my teacher Radion says, we can split a stitch into two parts. We measure 1/2, then shift it up or down, mirror it, and that gives us a clean knitted loop. Later we'll copy this across a grid. So let's do it. I already have half prepared, so let's mirror it. Let's make a node mirror. But before we need to use a match size to perfectly align it on x-axis. Yeah, now it's perfectly aligned on x-axis. Now mirror. Mirror is great because it stitches the points, but not polygons. If you see, it's two polygons in primitives. To fix that, we can add polypath, and now we got a simple primitive. Also, we can add some procedural control before mirror. We can add a curve node. It's kind of like a trim pass in After Effects. That way, we can control the stitch width later, like here. Now we can add another one match size to control the scale. Let's set up it around 0.2 in y-axis. Next we use copy and transform. Let's shift it by -0.5. And now we got a closed stitch system. Now we can use a grid. Let's reduce the size 1.05. Now we use points from volume. It's very handy because in one slider we can set the density. Also, we can put a check mark to add the p-scale attribute, but by default it's multiplied by 2. We need to turn it by 1, so we'll copy the same p-scale. Now let's add a copy to points. Now we have already our need copied. Can apply one more polypath to stitch another one primitives. Let's load the skull. We need to clean up a bit from unused attributes. We need to have UVs and normals. Later, let's add for each connected pieces. We're using connectivity with UV, and that's give us each UV island and class attribute. If you look, we can see that we have 7 parts, and for each of them we representing a class attribute. It's like an ID from 0 to 6. That's our trick. We basically flatten the 3D model into 2D UV space, and we cut out the neat pattern there and then project back onto a 3D skull. Okay, let's move on and add a vertex split node. Put a UV here as an attribute. Then we use attribute swap. We are swapping P position with UV. Boom, the model is flattened. Then divide node ends later on. Now we can create nulls. We will name it as mesh 3D space. Here will be mesh UV space. And the last one will be mesh borders UV space. Now we need to add a little VEX code. I also have it ready. We put in first input we using a neat grid, second mesh, third one UV mesh, and fourth our borders. We need to transform our grid in UV space, like from 0 to 1 by x axis. Let's use match size to move it properly. Let's align it by x axis and on y by minimum. Now we have a representation of UV space. Also we need to reduce size of our skull a bit. 0.1, 0.01. Here we create a node a clip, deleting all below the plane, and later on the last one we'll use an attribute swap. Here we're using attribute rest, so now we converting rest to P position. And here's our part of our head. Our knit is glued onto the skull surface. We can reduce a bit the point separation. First part of our setup is completed, I think. We have a perfectly aligned knit on our skull. Now we can try to transfer our texture by attribute transfer. Also we need to create attribute from map to load our texture as an CD attribute. And now we can transfer colors to one of our knitted surface. Also we can add some subdivide to increase the quality of our colors. I almost recommend you to increase polygon count. It could be also like in 2, multiply it in 2 times. Now we're using a sweep node, but we're not using tubes. we'll be generating strands. But we need to make sure that copy to point keeps p-scale. By default, it isn't. Because otherwise the sweep will mess it up, like here. And once it's fixed, we get nice knitted strands wrapping around. Like our p-scale multiplying by this radius value. We can add some variation with the rest attribute, so our lines will randomizely offset of each other. Let's add quality of our fibers. So let's add a rest. Later we add in attribute wop. We name it rest random. Dive in. We bind in attribute rest. Choosing a 3 float vector. And we can add it to position and mix. We can only use a mix. So if we put value 1, it going closer to our rest attribute before the sweep. By this we can create a bit of randomization. We add a random. Also, we can create some fit range. And put it on bias. Now area of our primitive is randomly offsetting from the center. And we can control this effect using our fit range. Next, we can add a bit of noise to avoid perfectly straight lines, and that give us more natural, sweeter look. We need to add subdivide also here to round a bit our lines. And now we can create another one attribute wop, call it curl noise. Let's add curl noise. Also we need p-scale, but sweep deleting p-scale by default, so we need to return it back. Let's go back, make a bind, put p-scale, it's a float. Also random. Add some seed, like 155. Later on we divide in our position by p-scale. We need to convert it to vector 4. Let's change it on 4D noise. Let's put it in position. Let's create add. We can add position and make it a bit complicated. Using multiply and multiplying our numbers, but we can also increase the randomization effect. Here we will reduce by half. And now we need power node to adjust our effect if we need it. And now that's all. We're multiplying, our noise, our p-scale, and also randomization per curve. And now we can add it to our position, and let's promote some parameters. Amplitude, roughness, let's go up, and we'll see how it's work. It's a lot of noise. Let's decrease it. Decrease the roughness also. Now we can see our fibers. It has a look like more sweeter. Later we will make our shader like hairs, so we need to make our normals. Let's create normals from using rest attribute, and we'll subtract our position. And we will need later to normalize it. So we're using rest and subtracting it from -p. We're using normalize, and let's rename it as calculate normals. We can preview the width of our fibers using attribute rename. We need to rename p-scale to width attribute. We need to go up using miscellaneous tab and use checkmark on shade over curves in viewport. Now we can see a representation of our fibers for preview. Let's reduce our width a bit. Well, let's multiply it like 0.1. Maybe a bit more, 0.05. Now we can rename it back. We can put it back like width to p-scale. Also we can put null. There will be our render node. Let's call it skull out. Let's put a render flag here. That one will be for preview. Now we can move to the render. Also, I prepared some HDA, and you can use it to create what I'm showing you. And using like two types of knit, like a chainmail with different settings. It's fully prepared setup, and you can use it for any kind of geometry, but you need to have one geometry for one setup, because different parts of geometry needs to be created in different setups. That's the main rule in this setup. For example, if you have like a man with a bottle or something, you need to prepare differently man and then a bottle. So if you need it, you can download it from the link below. I found some mistake. We put a divide node, but we didn't put anything. We need to uncheck convex polygons and also enable remove shared edges. And on the ends node, we need to put unroll with the shared edges. This keeps UV borders clean for cutting. Now we can go to the shading. Let's add some dome light. We'll add some Studio HDR. We'll add some materials. Let's make it skull. We need to put it on material tab. Also, we need to put a check mark to render it as strands. Also, we decrease tessellation subdivides and put it 0.25 to global scale multiplier. We'll create a camera. Like from this view. Let's create Redshift nodes output. We put our camera here in the render node. Let's zoom in a bit. We're using hair shader, so let's delete the standard one. Erase hair. Let's plug in. Also, we need to transfer our color attributes. Let's use Redshift point attributes. Let's put it in diffuse color. Put it the white color in reflection. We don't need transmission. Add a Fresnel. Let's make a bit of offset of our angular shift. Also, let's adjust a bit of IR. We'll add primary reflection weight. We need a diffuse for sure, because we have a texture and colors. Also translucency. For softer light, we open our Redshift render view. I like to use post effects. Let's open it. Like for example, desaturate highlights. and decrease the saturation. Also, let's add a bit of exposure. Let's add a bloom. Also, let's adjust color curves. Let's add some contrast. We can move dome light a bit. From here is just tweaking. Maybe you wanna a bigger stitches. Maybe you need different colors or extra noise. It's all adjustable. Like for example, we can use color correct and use our hue to create another colors. That's it. We built the setup, render it in Redshift, and this workflow works with almost any object as long as it has UVs. Even if it doesn't, you can generate it with Auto UV in Houdini. This was my first tutorial, so don't judge too hard. Thanks for watching. See you next time.